विद्यार्थी मित्रांनो, आजच्या आपल्या व्हिडिओमध्ये अजून आपल्याला काही प्रॉब्लेम जे आहेत इनडेफिनाइट इंटिग्रेशनवरील सॉल्व करायचे आहेत. तर आजची जी मेथड आहे, आजच्या या मेथडमध्ये इनडेफिनाइट इंटिग्रेशनवरचे प्रॉब्लेम सॉल्व करण्यासाठी आपण मेथड ऑफ रॅशनलायझेशनचा यूज करणार आहे. आणि मेथड ऑफ रॅशनलायझेशनचा यूज करून आपण काही प्रॉब्लेम सॉल्व करणार आहे. तर फर्स्ट जे प्रॉब्लेम आहे त्या इंटिग्रेशन साइन एक्स अपॉन 1 प्लस साइन एक्स इंटू डी एक्स. इव्हॅल्युएट इंटिग्रेशन साइन एक्स अपॉन 1 प्लस साइन एक्स इंटू डी एक्स. So let I is equals to integration sin x upon 1 plus sin x into dx. Then we use here method of rationalization. That is multiply numerator and denominator by conjugate factor of denominator. And conjugate factor of denominator is 1 minus sin x here. So integration sin x upon 1 plus sin x into multiply numerator and denominator by 1 minus sin x. So 1 minus sin x upon 1 minus sin x into dx. Therefore here is equals to integration. Then first we multiply the numerator sin x into 1. So write here sin x. Sin x into minus sin x. So minus sin square x. Again we repeat this. First we multiply here the numerator sin x into 1 sin x, then sin x into minus sin square x upon, then we multiply the denominator. Here 1 plus sin x, 1 minus sin x. That is here denominator is of the type in one bracket a plus b, another bracket a minus b. So we get a square minus b square. By using this result, so we get here 1 square that is 1 minus sin square x into dx. dx means integrating with respect to x is equals to integration sin x minus sin square x, that is numerator as it is. म्हणजे न्यूमरेटर हा जसाच्या तसाच लिहायचा आपल्याला, त्याच्यामध्ये काहीही बदल करायचा नाही. डेनॉमिनेटर सॉल्व करायचं आहे. इन डेनॉमिनेटर 1 मायनस साइन स्क्वेअर एक्स, in denominator 1 minus sin square x. So we know that the first fundamental identity sin square x plus cos square x is equals to 1. Therefore cos square x is equals to 1 minus sin square x. So we write here this 1 minus sin square x is equals to cos square x into dx is equals to integration. Then this can be written as here sin x upon cos square x. So sin x upon cos x into 1 by cos x into dx. Here sin x upon cos square x can be written as sin x upon cos x into 1 by cos x. If we solve this, then we get sin x upon cos square x. Sin x into 1, sin x. Cos x into cos x, cos square x into dx. Minus integration sin square x upon cos square x into dx, sin square x upon cos square x into dx is equals to integration by using the formula. We know that in 10th standard sin x upon cos x is tan x, 1 by cos x, that is sec x into dx, minus integration sin square x upon cos square x, so we write here tan square x into dx is equals to, here we find the integrations of sec x into tan x into dx, and we know that sec x into tan x is the derivative of the function sec x. Sec x into tan x is the derivative of the function sec x. Therefore integrations of sec x into tan x into dx is sec x. Because here we use the definitions of the indefinite integration, derivative and integrations are anti-process. Minus here integration tan square x, and here tan square x can be written as sec square x minus 1. By using the second fundamental identity, tan square x can be written as sec square x minus 1. We know that the second fundamental identity, 1 plus tan square x is equals to sec square x. Therefore, tan square x is equals to sec square x minus 1 into dx is equals to this sec x as it is, minus sign as it is, integration. Use here subtraction rule. So negative into positive, negative. Integration sec square x. Integration sec square x into dx. Negative into negative, positive. Integration 1 into dx. Again we repeat this. This is equals to sec x as it is. Then here minus sign, integration. Here negative into positive, negative, sec square x into dx. Negative into negative, positive, integration 1 into dx is equals to sec x minus sec square x is the derivative of the function tan x plus integration 1 into dx. 1 is the derivative of the function x plus integrating constant c. And this is the required solutions of the given problem. Next, again we evaluate one problem on indefinite integration. Evaluate integration tan x upon sec plus tan x into dx. Evaluate integration tan x upon sec x plus tan x into dx. मित्रो, इंटिग्रेशन इव्हॅल्युएट करण्याचं एक स्किल आहे. जितकी जास्त प्रॉब्लेम तुम्ही सॉल्व करसाल तितकी तुमची याची प्रॅक्टिस चांगली होणार आहे आणि तुम्हाला मग हे प्रॉब्लेम सॉल्व करण्याला कुठलीही अडचण जात नाही. कारण बऱ्याचशा विद्यार्थ्यांची पेपर जेव्हा बोर्डाचा सॉल्व करतात किंवा CETचा किंवा JEEचा, तर त्यांना कुठलं प्रॉब्लेम कुठल्या मेथडमध्ये बसते हेच समजत नाही. कारण याच्यामध्ये प्रॉब्लेम कसं सॉल्व करायचं, ते प्रॉब्लेम कुठल्या मेथडमध्ये बसते हे तुम्हाला समजायला पाहिजे. आणि मेथडमध्ये बसल्यानंतरच त्याला इव्हॅल्युएट करता येते. आणि मेथडमध्ये केव्हा बसते हे तुम्हाला प्रॅक्टिस केल्याशिवाय, जितके जास्त प्रॉब्लेम तुम्ही सॉल्व करसाल तेवढी तुमची चांगली प्रॅक्टिस होईल आणि त्यानंतरच तुम्हाला हे प्रॉब्लेम सॉल्व करता येतील. तर आज आपण याच्यावर आणखी एक इंटिग्रेशन्सवर हा व्हिडिओ बनवत आहे. म्हणजे लाईव्ह आपण माझ्या यूट्यूब चॅनलवरून तुम्ही पाहता. काही नवीन जर हे असतील, ऑडियन्स असतील, काही विद्यार्थी असतील, तर त्यांनी जरूर या माझ्या चॅनलला म्हणजे व्हिडिओला लाईक करायचं आहे आणि चॅनलला सबस्क्राईब करायचं आहे. म्हणजेच अशा प्रकारचे नवीन व्हिडिओ तुम्हाला फारच लवकर बघण्यास मिळतील. कारण आपण एक नवीन कन्सेप्ट चालू केलेला आहे. तो कन्सेप्ट आहे डिजिटल लर्निंग. हे सर्व आता आपण डिजिटल लर्निंग घेत आहे. I is equals to integration tan x upon sec x plus tan x into dx. This is the given problem. Then here tan x can be written as sin x upon cos x. Sec x can be written as 1 by cos x plus tan x. We know that tan x sin x upon cos x into dx. We use here the formula for tan x sec x. Tan x can be written as sin x upon cos x. Here tan x. So tan x can be written as sin x upon cos x, sec x 1 by cos x plus tan x sin x upon cos x into dx is equals to integration sin x upon cos x, that is numerator as it is. Here denominator equal, so we add the numerator 1 plus sin x upon cos x, 1 plus sin x upon cos x into dx. Then if by taking reciprocal, then cos x get cancelled. If we take the reciprocal, then cos x cancel. So is equals to integration sin x upon 1 plus sin x into dx. And then we use here method of rationalization, that is multiply numerator and denominator by conjugate factor of denominator 1 minus sin x. So sin x upon integration sin x upon 1 plus sin x into multiply numerator and denominator by conjugate factor of denominator, that is 1 minus sin x, 1 minus sin x upon 1 minus sin x into dx. Therefore here first we solve the numerator. So is equals to integration sin x into 1 sin x. Sin x into minus sin square x. Then we multiply here the denominator. This is of the type a plus b, a minus b. So we get a square minus b square. So 1 square, that is 1, minus sin square x into dx is equals to, again here numerator as it is, by using the first fundamental identity. We know that the first fundamental identity, sin square x plus cos square x is equals to 1. Therefore from this, cos square x is equals to 1 minus sin square x. So 1 minus sin square x is equals to cos square x into dx is equals to integration sin x upon cos square x. Sin x upon cos square x can be written as sin x upon cos x into 1 by cos x into dx. Then here minus sin square x upon cos square x into dx. So integration sin square x upon cos square x into dx. Again we repeat this, sin x upon integration here is equals to integration sin x upon cos square x. So sin x upon cos square x can be written as sin x upon cos x into 1 by cos x into dx. Here minus sign, so we write here minus sign. Integration sin square x upon cos square x, integration sin square x upon cos square x into dx is equals to integration sin x upon cos x tan x into 1 by cos x, we know that sec x into dx, minus here this integration sin square x upon cos square x tan square x into dx is equals to here, we know that sec x into tan x is the derivative of the function sec x, therefore here integration is sec x, minus integration tan square x, use here the second fundamental identity, 1 plus tan square x is equals to sec square x, therefore sec square x is equals to, there 1 plus tan square x is equals to sec square x, therefore tan square x is equals to 1 minus sec square x minus 1 into dx is equals to here sec x as it is minus, use subtraction rule, integration sec square x into dx, this is negative into negative positive, integration 1 into dx is equals to here sec x as it is minus as it is integrations of sec square x into dx. Again we know that sec square x is the derivative of the function tan x plus, so right here plus, integration 1 into dx, so 1 is the derivative of the function x plus integrating constant c. So in this way we evaluate the second problem on the indefinite integration. Next, again we evaluate one problem on indefinite integrations. All the functions are trigonometric functions here. Evaluate integration under root 1 plus sin 2x into dx. We evaluate integration under root 1 plus sin 2x into dx. Let I is equals to integration 1 plus sin 2x into dx. Then here first we solve the function. And after solving the functions, here square and root cancel, and then we find the integrations of the simple functions here. So is equals to integration under root 1 by using the first fundamental identity sin square x plus cos square x plus here sin 2x, we know that the double angle formula sin 2 theta 2 sin theta into cos theta. Similarly sin 2x 2 sin x into cos x into dx is equals to here integration sin square x plus 2 sin x into cos x plus cos square x. This is of the type a square plus twice ab plus b square equals to a plus b whole square. So sin square x plus 2 sin x into cos x plus cos square x can be written as sin x plus cos x whole square into dx. And then here square and root cancel. So is equals to integration sin x plus cos x into dx. Here square and root cancel, then sin x plus cos x into dx. Then we use here addition rule is equals to integration sin x into dx plus integration cos x into dx is equals to integration sin x into dx. Sin x is the derivative of the function minus cos x plus cos x is the derivative of the function sin x plus here integrating constant c. And this is the solutions of the third sum on indefinite integration. म्हणजे तुम्ही फक्त माझं चॅनल पाहिलं आणि त्याच्यावरून जर अभ्यास केला तर तुम्हाला कुठेही घर सोडून जाण्याची गरज नाही. सर्व जे काही इनडेफिनाईट इंटिग्रेशन्स हा जो युनिट आहे याच्यामध्ये इम्पॉर्टंट युनिट आहे, कारण याचा फिजिक्समध्ये सुद्धा तुम्हाला यूज आहे. तर त्या दृष्टिकोनातून हा एक इम्पॉर्टंट युनिट आहे, याचा चांगला स्टडी तुम्ही करायला पाहिजे. अजून आपण एक प्रॉब्लेम घेऊ, याच्यावर टिग्नोमेट्रिक फंक्शन्सवरच आहे. इव्हॅल्युएट इंटिग्रेशन अंडर रूट 1 मायनस कॉस 2x इंटू dx. So let I is equals to integration under root 1 minus cos 2x into dx, and we know that the double angle formula 1 minus cos 2x 2 sin square x. So we write here is equals to integration under root 2 sin square x into dx. Therefore here this 2 can be written as under root 2 here, integration square and root cancel sin x into dx is equals to here under root 2 as it is, integrations of sin x into dx, so we get minus cos x plus integrating constant c. This is the solutions of the next sum on indefinite integrations. Again we solve one problem on indefinite integrations. Evaluate integration sin 4x into cos 3x into dx. So let I is equals to integration sin 4x into cos 3x into dx. Then we know that the one standard result in 11th standard, apply sin a into cos b is equals to sin of a plus b plus sin of a minus b upon 2. That is, we know that in 11th standard sin a plus b plus sin a minus b is equals to 2 sin a into cos b. So this can be written as sin a into cos b is equals to sin of a plus b plus sin of a minus b upon 2. By using this result is equals to integration, this can be written as here sin a plus b, that is here a is 4x, this 4x is a, and 3x that is b. So sin a plus b means 4x plus 3x, 7x, so sin 7x, plus sin a minus b, that is 4x minus 3x, so we get x, so plus here sin x upon this 2 as it is into dx. Then here 1 by 2 is constant, so is equals to 1 by 2. In bracket, apply here addition rule, integration sin 7x into dx, integration sin 7x into dx, plus integration sin x into dx, integration sin x into dx is equals to this 1 by 2 as it is. Then we find here the integrations of sin 7x into dx. We find here the integrations of sin 7x into dx. So we know that the formula integrations of sin ax into dx, so minus cos ax upon a. Similarly here we know that the integrations of the sine function minus cosine, so minus cosine 7x upon derivative of 7x, that is 7. Then integrations of sin x minus cos x plus integrating constant c, and this is the required solutions of the next sum on indefinite integration. So dear student, in this way we solve some problem on indefinite integration. So if you like my if you watch my video, then you like and subscribe my channel. Okay, thanks.